Question 79. So for z equal to not equal to minus I, let fz be the exponential of 1 by z plus I minus 1. So which of the following is true? So we have been given the fz function is exponential of 1 by z plus I minus 1. So we can expand this equation, the exponential part as 1 minus 1 plus z plus I plus 1 by 2 factorial z plus I whole square, and it will be minus 1. So putting it, simplifying it, we can get, so 1 minus 1 will cancel out, so 1 by z plus I plus of 1 by 2 factorial 1 by 2 factorial multiplied by 1 by z plus I whole square. So here the principal part has infinitely many terms. So the function has an essential singularity, at z equal to minus I. Okay, so for zeros of fz, so we can write the exponential of 1 by z plus I minus 1 equal to 0. So it will be exponential of 1 by z plus I equal to 1, which we can write it as equal to exponential of 2n pi I. Okay, so from here we can simplify it, that 1 by z plus I is equal to 2n pi I, or z plus I equal to 1 by 2n pi I, and z is equal to 1 by 2 pi ni minus I, where n belongs to the, is an element of the set of the natural numbers. Okay, so there are infinitely many zeros, right? So infinitely many zeros of fz, and also zn tends to minus I as n tends to infinity, right? So f has a sequence of zeros that converges to a essential singularity of f. So infinitely many zeros, there is a sequence of zeros, right, that converges to an essential singularity of f. So the correct option for this question 79 is 4. Question 80 says that let f be a holomorphic function on the open unit disk D, where z belongs to the complex plane and mod of z is less than 1. Suppose that mod f is greater than or equal to 1 on the disk D, unit disk D, and f0 equal to y. We have to find the possible the value of f of half. So that is our, that we have to find the f of half. So let us consider that gz is equal to 1 by fz. Okay, and since mod of f is greater than equal to 1 on D, on this unit text Z, and is holomorphic in D, so is G of Z, right? And moreover, we have the mod of GZ is less than equal to 1 for all Z. So GZ is also holomorphic, right, in D, in the unit text D, and G mod of GZ is less than equal to 1 for all Z, right? So hence by Liouville's theorem, so what is the Liouville's theorem in complex analysis? That a bounded holomorphic function on the entire complex plane must be constant. So in our case, G is constant, right, over the entire complex plane. So is f. So we have been given that f of 0 is I, it is given. So f of 0 is I. It implies that fz is also I for all z an element on the unit disk D. So f of half will also be I. So in our case, the correct option is 2, that is f of I, the f of half, the value of f of half will be 2, that is I, option 2. This is the correct option.